Hello everyone, I'm Kevin, and this is part 5 in my Modding Minecraft 1.8 series. In this video, we'll be starting on the Ninja Monkey mod that I showcased in my previous video. We'll be adding bananas, banana smoothies, and the Ninja Star projectiles. So let's get started. We'll start by adding our new items. In the init folder, open the item.java class. Scroll down to the bottom of the item declarations and add 3 new items: banana, banana smoothie, and the Ninja Star item. Then scroll down to the bottom of the class and initialize them with the getRegisteredItem function. Then you can save and close. Then open the item.java class in the item folder. Scroll down to the bottom of the register item function at around line 1048. And register the 3 new items. Here we register the banana and banana smoothie and Ninja Star items as elements 432, 433, and 434, or as the next unused elements in the list. The banana and banana smoothie are registered as item food types. The constructor parameters for the item food is the hunger heal amount, the saturation amount, and the boolean that sets whether or not the wolf can eat this food. We assign them the Food tab in the Creative menu. setUnlocalizeName is the reference name used in the lang file. The Ninja Star is registered as type item Ninja Star, which doesn't exist yet. We need to create this item type class because the Ninja Star will have special properties and actions when used by the player, which need to be defined. We assign the Ninja Star item to the Combat tab in the Creative menu. Now we can save and close. Now open the RenderItem.java class in the Client Renderer Entity folder and scroll down to the Register Items function at around line 527 and register the 3 new items in the renderer. Then you can save and close this class. There's something important to understand here. The Ninja Star, like the arrow and other projectiles in the game, are actually made of 2 different objects each: the item class and the entity class. The item class is the item that the player picks up or crafts and holds in his inventory or hands. The entity class is the object that gets spawned into the world when the item is used. It has to do with functionality. An item is a static object. It has only the most basic physics and cannot interact with the world or other objects in the world. Entities, on the other hand, have all the physics routines, They have motion, velocity, they react to gravity, and they can collide and interact with the world and other entities. We'll start with the item class for the Ninja Star and make it a craftable object. Now in the item folder, create a new class. We call this class Item Ninja Star and click Finish to create. We start by adding the imports we'll need. There will be more to add later when we create them, but these are the ones we need for now. We extend this class from the item class to inherit all the item properties and functions. Then a constructor that simply sets the maximum stack size for this item to 64. These functions are inherited from the item class and return whether or not this item can harvest blocks when used, and whether or not it can be repaired. We override them and set them to return false for both. The Ninja Star is not a tool and can't be used to harvest, and it doesn't take damage, so there's no need to repair it. This next function, onItem right click, is of course called when the player clicks the right mouse button while holding the item. This conditional statement checks if the map is in creative mode. If not, the item stack is decremented by 1. The swing item function called on the player activates the arm swinging animation. The set item in use function is called to make sure that no other action can be performed while the item is in use. Finally, we call the play sound at entity function and pass the random bow sound to play at the player's location. The last two parameters for this function are the volume and the pitch at which to play the sound. These are the same values used by the bow. Here we check if the world is remote. Then we create a new object of type Entity Ninja Star, called Star. We will create this class later. The parameters for this class are the world object and the entity from which the Ninja Star is being fired. The Ninja Star entity's constructor will automatically set the Ninja Star's velocity vector to the player's facing direction. The Ninja Star's initial velocity was too slow, so here I multiplied its motion vector by 2 to double its speed. Until now, the Ninja Star entity only exists in memory, so after creating the Ninja Star entity and setting its motion vector, we spawn the entity into the world so it can go on its merry way. That's all for this class. You can save and close. Now we can add the crafting recipe for the Ninja Star item. Open the recipesweapon.java class in the item crafting folder. We add a new recipe to craft 5 Ninja Stars from 4 flints and an iron ingot. The parameters for the add recipe are the item stack, which we define as 5 Ninja Star items, and an object array of 3 strings of 3 characters each, which correspond to the 3x3 crafting grid, followed by the definition of each character used in the strings. In this case, the character I is the iron ingot and the character F is the flint. You can use any non-special characters for the recipe definitions. Now we create the Ninja Star entity projectile that gets spawned when the Ninja Star item is used. Right-click on the Entity Projectile folder and create a new class. Call it Entity Ninja Star and click Finish to create. First, we need to extend this class from Entity Throwable. Then we add all the imports we'll need. Again, there will be more added to this import list later. We need to create a couple of variables. The random tilt integer will hold a random angle that will tilt each individual Ninja Star as they leave the thrower. And the on-fire boolean will hold whether or not to inflict fire damage on the entity it hits. Now we need to create 3 constructors. The first one only contains the world as its parameter. The second one has the world and an entity. And the third has world and XYZ parameters. They all initialize the random tilt with a random integer between 0 and 360 and the on fire to false. Then we need to add public set and get functions for the random tilt and on fire variables. This is a custom function that we'll need. It takes a moving object position as a parameter, which is a variable returned from the onImpact event. A moving object position will contain a collision object, either a block or another entity, and the location of the collision. When the onImpact event returns a collision with another entity, we will call this function to inflict the appropriate damage on that entity. The first line of this function retrieves the entity that was hit and calls the attack entity from function on that entity. The attack entity from function takes a damage source as the first parameter with the attacking entity as its parameter, which in this case is the getThrower property. The second parameter of the attack entity from is the amount of damage to inflict. Then we check if the Ninja Star entity is on fire using the getOnFire function we created above, and if so, we set the hit entity on fire with the setFire function. The parameter for the setFire function is the amount of time in seconds to burn the hit entity. This destroy self function simply spawns a small smoke particle at the location of the Ninja Star and calls the setDead function inherited from entity. The setDead function destroys the Ninja Star entity and removes it from the world. We'll call this destroy self function when the Ninja Star hits a solid block or another entity. This onImpact event function is inherited from the entity throwable class and is called when the Ninja Star collides with a block or the bounding box of another entity. The moving object position will contain a reference to the type of object that was hit, the actual object that was hit, and its location. This conditional statement checks if the type of object hit is a block. Response code for a block collision will go here, and response code for an entity collision will go here. Let's start with the block collision code. This line retrieves the actual collided block using this obfuscated function in the moving object position object and stores it in block. Another conditional statement checks if the collided block is tall grass, a vine, flowers, mushrooms, reeds, grown veggies, or a snow layer. If so, here we break the block and allow the ninja star to continue on its path. Else, here, the ninja star has collided with a solid block and is destroyed. So in the else block, we can simply call the destroy self function, since it hit a solid block. If the collided block is a breakable one, then we need a few variables to break and harvest it. These three lines retrieve the block pose, the block state, and the tile entity variables for the collided block. These three variables are required to harvest a block. We then check if the ninja star thrower is a player or a tameable entity. Breaking a block requires a reference to the player breaking that block. Therefore, there will be a slight difference between the way a ninja star thrown from the player and a ninja star thrown from a monkey will break a block. For the player, the process is simple. First, we cast the thrower to type entity player. Then we make a call to the world's destroy block function, passing the block's position as the parameter. This will destroy the block. Then we call the block's harvest block function, passing the required parameters, the world object, the player, the block pose, the block state, and the tile entity for that block. This function will make the block drop the items that they would normally drop if you were to break them with a weapon or a tool. For the monkey's ninja star, things are a little more complicated. As I said, we need a reference to the player to be able to call the harvest function. So what we need to do is cast the thrower to type entity tameable so we can use the getOwner function to retrieve the player. We check to make sure that the tameable entity is not null and that he is indeed tamed. A glitch here could result in a catastrophic crash due to a null pointer if we don't. Now we can use the tameable entity's getOwner function and cast it to entity player type in order to get a reference to the player who owns the monkey. To be safe, we check to make sure that this reference is not null. Then we can destroy and harvest the block the same way as above. Now for the entity collision. First thing is to check to make sure the hit entity is not null. At the end of this block, we destroy the star because no matter what the result of the entity collision is, the ninja star will be destroyed in the end. Then again, we need to separate the routine into two blocks. One for if the thrower is a player, and one for if the thrower is a tamed creature. For the player's ninja star, we simply call the inflict damage function we created earlier and pass the moving object position as the parameter. If the thrower is a tameable creature, we then need to split the hit entity into two more conditions. If the hit entity is another tameable creature, we cast the hit entity to entity tameable, then check to make sure that the tameable entity is not null. And only if the tameable entity is not tamed do we inflict damage, because we don't want stray ninja stars to harm other tamed pets. Else if the hit entity is not a player do we inflict damage. We don't want the owner or other players to be hurt by stray ninja stars either. So this block ensures that the monkey's ninja stars can only hurt untamed animals and non-players. And that's all for the ninja star entity class. You can save and close. Now that we're finished creating the entity ninja star class, we can reopen the item ninja star class in the item folder and add the entity ninja star class to its imports. Now we need to create a custom renderer for the ninja star entity. And for that, we'll go into manually drawing quads to create models. Let's create a new class in the Client Renderer Entity folder. Call it Render Ninja Star and click Finish to create the new class. We add the imports for this class. and we extend this class from the render class. The constructor, which simply calls the parent constructor, and a resource location variable to hold the texture. Two override functions for returning the entity's texture, we then override the doRender function and cast the entity to type entity ninja star and call the custom doRender function. Then we create the custom doRender function with an entity ninja star parameter. This is where we will render our ninja star model. First, we call the bindEntityTexture function, which is inherited from the render class. This function in turn calls the getEntityTexture function above and binds the texture to the ninja star entity. Then we make a call to the OpenGL manager and set the texture color to white. Finally, we push the matrix to prepare it for operations. A matrix is a mathematical two-dimensional array used to make vector calculations. There's tons of information on the net about matrices, and if you would like to learn more about them, I encourage you to look it up. However, for this tutorial, you don't need to know how matrices work, only how to use them. The simplest way to picture a matrix is as a kind of 3D stencil. When we create a model in 3D space, we don't create the model in the space itself. We create it on a matrix, which can then be moved, rotated, and scaled around the matrix's 0, 0, 0 point in 3D space. First, we move the matrix to the world position of the ninja star. This second line rotates it on the y-axis so that it's facing in the direction that the player is facing. Then we get the random tilt for this star and use it to rotate on the x-axis. These two lines get a reference to the tessellator and a reference to the world renderer. The tessellator is the class that generates quad faces from a list of vertices, and the world renderer is the main render system that draws the generated faces. Then we call the enable rescale normal function in the GL manager. This function performs an OpenGL operation which sets a flag to enable uniform normal rescaling. Then we set a scale variable to use as a global scaling value for the matrix and normals, and we scale the matrix down using that variable. Here we set the normal's facing direction. This function is used to set the normal direction of individual vertices or a whole quad. Now we can start drawing the quads for the ninja star model. We draw the model on the 0, 0, 0 point since the model is drawn to the matrix, which acts as a 3D stencil, and the matrix is moved, scaled, and rotated before the model is drawn to the screen buffer. So how do we manually create quads? Well, it starts with a Start Drawing Quads call from the World Renderer. And ends with a draw call from the tessellator. Everything between these two statements is a quad definition. So how do we define a quad? You can use a sheet of grid paper or a 3D modeling package like Blender to plot vertices in 3D space. Here's the quad that will make up the model for our Ninja Star entity. The Minecraft engine only supports quads, so every face of your model must have 4 vertices. And when plotting vertices for a quad, you need to define them in order in a clockwise direction. Vertex 1's coordinates are -2, -2, 0. Vertex 2's coordinates are 2, -2, 0. Vertex 3's coordinates are 2, 2, 0. And vertex 4's coordinates are -2, 2, 0. The normal of this quad points up as we've defined with the GL normal 3F function. The next thing we need to figure out is the texture UV coordinates for each vertex. Now we want to map this texture onto the quad. Each vertex has 2 floats that represent the UV coordinates. UV coordinates are not measured in pixels, but as floats between 0 and 1. So if we superimpose our quad on top of this image, the coordinates for each vertex would be 0, 0 for vertex 1, 1, 0 for vertex 2, 1, 1 for vertex 3, and 0, 1 for vertex 4. So we have all the data we need to code the Ninja Star model, which is made of just one quad. For each vertex, we insert an Add Vertex with UV function call to the World Renderer. The first 3 parameters are the vertex coordinates, and the last 2 parameters are the UV coordinates. Now there's one small problem with this model. It's called backface culling. The renderer in Minecraft culls back faces, meaning that the renderer only renders one side of the quad. Only the side that the normal is facing will be rendered. Normally, there's a flag in OpenGL and DirectX to turn backface culling on or off, but Minecraft doesn't appear to have that option coded in the renderer. So short of recoding the World Renderer class, there's no way to turn backface culling off. The only way to solve this problem is to flip the quad we just created around 180 degrees and render it again facing in the opposite direction. So we rotate the matrix 180 degrees. Then we can simply copy the same quad draw block and paste it in after the matrix rotation. The renderer will now render one quad, flip around 180 degrees, and render it again with the quad face pointing in the opposite direction. We finish off the rendering routine by disabling the Rescale normal flag and popping the matrix, which returns the matrix to its previous default translations before we pushed it onto the stack. Finally, we call the parent doRender function passing the required parameters. And we're all done with the render class for our NinjaStar entity. You can save and close. Now we need to add the NinjaStar entity to the render manager so it can be rendered into the world. Open the renderManager.java class in the Client Renderer Entity folder. Scroll down to the end of the render registry list at around line 200 and insert our NinjaStar entity just after the lightning bolt entity. The NinjaStar entity class also needs to be added to the imports. You can simply hover over it and click the Import Entity NinjaStar in the pop-up. And that's all for this class. You can save and close. We also need to add the NinjaStar entity to the entity list so it can be spawned into the world. Open the EntityList.java class in the Entity folder. Scroll down to the end of the entity registry list at around line 376 and add the NinjaStar to the list with an index ID number of 102 or the next unused index. The entity NinjaStar also needs to be added to the imports. Then save and close this class. Every entity that isn't controlled by a player or by the AI system needs to be tracked so that the engine knows where it is at all times, and which chunk of the map to load and unload. So the NinjaStar needs to be added to the tracker classes so it can be spawned into the world and tracked along its trajectory. Open the EntityTracker.java class in the Entity folder and scroll down to the bottom of the constructor at around line 182. Here we insert another else-if statement and check if this obfuscated variable is an instance of Entity NinjaStar. If so, we call the addEntityToTracker and we pass the obfuscated variable as the first parameter, which is a reference to the entity. The other parameters are the tracking range, the update frequency, and a Boolean for whether or not to send velocity updates to the client server. Again, the Entity NinjaStar class needs to be added to the imports. And you can save and close this class. Now open the EntityTrackerEntry.java class in the same folder. Scroll down to around line 560 and add another else-if statement to return a new packet object for the NinjaStar entity. We use the packet number 91 because it's not being used by any other tracked entity. And again, we need to add the NinjaStar to the imports. And you can save and close this class. One last class to modify. Open the nethandler playClient.java class in the client network folder. And scroll down to around line 408. Again, we need to add another else-if statement here to handle packet 91, which is the Ninja Star tracker. And we need to add the entity Ninja Star to the imports again. And that's all. You can save and close this class. Now that our Ninja Star is done, let's get to the banana and banana smoothies. First, we'll add the recipe for the banana smoothies. Open the recipesfood.java class in the item crafting folder. And at the bottom of the recipes list, we'll add a recipe to craft 2 smoothies from a bucket of milk and a banana. Then save and close. Now for the banana. As it is now, the banana doesn't spawn anywhere in the world, so let's add them. Expand the block folder. You'll find 2 classes named block new leaf and block old leaf. Open the block new leaf class. At around line 45, this is the function that is called when a new leaf is broken. As you can see, if the leaf type is dark oak, there's a random chance of an apple spawning. So we'll add an else if to this statement for jungle leaves. And we'll give jungle leaves a 1 in 10 chance of dropping a banana. Now you can save and close new leaf and open block old leaf. And here we do the same thing. The function you're looking for is at around line 82. Again, we add an else if statement to have a 1 in 10 chance to drop a banana from jungle leaves. And we're all done with the code. Now we need to get our assets in order and into the inject folder. Let's take a look at the textures we'll need. The banana, the banana smoothie, and the Ninja Star. They're all 16 by 16 PNGs with transparent backgrounds. We'll also need a JSON model for each item. This is the banana JSON file, which is a standard item model with standard properties. The first line tells the engine that this item model is an automatically generated model based on the texture file. And the first person and third person alignments are the same ones that most items use. The banana smoothie has all the same values, the only difference is the texture name. The Ninja Star alignment values are very different, however. I had to rescale and change the position of the Ninja Star to properly place it in the player's hands in third person, and to align it to the bottom right corner of the screen in first person. Now open your MCP inject folder, and under Assets, Minecraft, create a new folder called Textures. Under Textures, create another folder called Items. Now copy the 3 textures to this Items folder. Now go back to the Minecraft root folder and create another folder called Models. And in the Models folder, create another folder called Item. Then copy the JSON model files to the Item folder. Next, we need to open the lang file in the lang folder. If you don't have the lang file in your inject folder, I covered how to extract it from the game jar in my first tutorial on adding blocks. In here, we give the 3 new items in-game names using the unlocalized names as references. And we're all done. In the next video, we'll be starting on the monkey. Now let's compile and test out our new Ninja Star. As usual, you can download the code and assets for this tutorial in the description below. If you like this video, please hit the like button and subscribe for more. So here it is, a Ninja Star projectile.